Hello, everyone. So welcome to Theo-MathProblemSolver. In this particular episode, I'm so excited to take you through the journey of antiderivatives. And but what is this antiderivative about? Stay with me even as we explore that together. And at this point, if you have not subscribed to my channel, please do so. Like, comment, and turn on your notification button so that anytime I release new content, you'll be the first to receive that. All right. So when you talk of anti-derivative, we basically say that it's just a concept in calculus that allows us to kind of find the reverse of differentiation. Already we know, differentiation so far. In our previous episode, we talked a lot about the differentiation. But what is the relationship between differentiation and then the anti, derivatives? So the anti, as the name implies, anti, which is always like the opposite of something, which is basically means the reverse or the opposite of differentiation. So that's what anti-derivatives about. And another interesting thing about the anti-derivative is that it refers to just the result of an indefinite integral. And as we go on, we'll touch on what the indefinite integral is about, so that we can really understand that. So stay with me, even if we do that together. Now, there's an interesting theorem that I would want us to talk about. And what is the theorem about? So we claim that the derivative of the function f of x is a set of functions, so big F of x plus c, such that anytime we kind of take the derivative of that, we get the original function back. Okay, that is so important. And that's what I said, that is just the reverse, because we said that with the antiderivative, we said is just the reverse of the differentiation. Okay, so anytime we take the differential of the antiderivative, we get the original function back. Okay, and I also want to point out that the constant c is what we refer to as the constant of integration. I will talk more about that as we progress in this journey. So stay with me. Don't run away, please. All right. So let's look at some basic, properties of of the antiderivative. All right. So we are looking at some of the, properties of the indefinite integral. And then the first property I want us to look at is that anytime we kind of take the integral of a constant, let's say k, we kind of get kx plus c. But how do we get this? So as I mentioned that the antiderivative is the reverse of differentiation. So how are they related in some way? So this is how they are related. Now over here, if I ask you to find the integral, suppose that over here so over here we claim that k is some constant. Okay, suppose k is a constant. Let me be more specific here. Let me just get rid of this one rather, so that I can explain it well. All right, so let's get going. So suppose that k is some constant. Okay, suppose that k is some constant. Then we claim that when we take the integral of that constant, okay, we get So what happened is that I asked myself that what function has its derivative, okay, to be k. What function should I pick such that when I find its derivative, the result is k, okay, and that is what kx, okay. We have to add k, so we have kx as a result. But there's something that we have to do to this. Remember that when we're talking about the theorem, we normally have to add a c to the set of functions. Okay, we need to add a c to the antiderivative, and uh and what is the rationale behind that? What's the rationale behind that? You see, the function, you know, the original function f of x may have had a constant on it. So it is imperative that we kind of add c to that, you see, because um, remember that we said that the f of x is a, we said that the antiderivative of f of x is a set of functions, okay? Which means that it's not unique, right? Which means that the result is not unique. The result of this is not unique because we may not we don't have an idea of what C may be. C may be 1, 2, 3. So it means that this result is not unique. So the result, so you have to have it in mind that the result of the indefinite integral is not unique. Okay, as the name implies, it's indefinite. Once something is indefinite, we kind of uh, it kind of says the result of that could not be kind of unique. Okay. Okay. So the reason why that's the more reason why I know many people know how to solve it, but they don't understand why we add a c. Okay. Because and the reason we add it, as I mentioned, is that it's a family of functions. Okay. And you may not know whether the function had a constant attached to that. So we do that just to get rid of that ambiguity, okay? To get rid of that ambiguity. So there's a reason why I'm spending time on this. I'm not going to explain that again. The reason why we add c is that the original function f of x may have had a constant on it. So that's why we add that. And usually because we said the antiderivative is the reverse of differentiation. For you to check your result, sometimes we have the easiest way is to differentiate the result you get. And if you're able to get it, if you're able to get the integrand, let me point out here that the k over here is what we call the integrand. Okay, integrand. Okay, very important. So let's take note of that. And we call c as the what? As the constant of what? Integration. So please, let's take note of that. Very important. Now let's look at the next property of the indefinite integral. So the integral of x to the power k. So what happened for us to integrate such a function? What happened is that according to the law says that, or the property says that, increase the power of x by 1. So we increase the power by 1. Then we divide it by the increased power, okay? Then as usual, we'll add our c. And as let me stress that one more time. The reason we add a c is that we do not know, maybe the original function may have had a constant c on it, okay, and that is why we add c, okay. And remember, as I told you, this results a family of functions. So if it's a set of function or family of functions, it just means that this result is not unique. So just bear that in mind. Bear that in mind. It's so important. The result of, let me stress on that, the result of the indefinite integral is not unique. Just to take note of that. Very, very, very important. Okay, very, very, very important. And then the third law is that the integral of the exponential function of e to the power x ax is what? So what happened is that I maintain the function, I maintain the integrand, and I divide it by divided by the coefficient of x, and that is a. Okay, that's the easiest way. Then I divide it by the coefficient of x. Okay, so that is a. Very, very important. So important. So let's take note of that. Over here, remember a is just a constant. Okay, very, 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 very important. Let's take note of that. And at this point, if you have not subscribed, please do so. Like my content, turn on your notification button so that anytime I release new content, you'll be the first to receive that. All right, so I want us to look at what we call the linearity. Okay, so I would stress on that. With this property, we call it the linearity property. Okay, very, very important. So linearity. With the linearity property, what are we saying? We claim that if you have two functions f of x, okay, and we add or subtract them, suppose that f and f of x and then g of x are some continuous functions. We claim that when we take the integral, the result is just as because of the linearity property, we have this interesting, result. Okay, because of linearity, we have this. And this is a very, very, important result. So I would want you to kind of, take note. We'll take some examples so that you would be able to kind of appreciate it well. Okay, so then don't get worried. We'll solve more examples so that you would kind of you would appreciate it. So stay with me. You will be fine. So stay with me. You'll be fine. So at this point, maybe I may want us to look at one more property, then we can, look at other stuff as well. So what about if I have some um trig functions? If I have the integral of the sine function, what happened to that? So over here, what I ask myself is that what function, you know, what function has its derivative to be sine x? Okay. What function do we differentiate to get sine x? And that is what minus cosine x. Then we add up constant c. Okay, very important. And then the integral of the cosine of x is what? Is sine x plus c. Now, what if I take the integral of sine of, let me use kx. So the integral of sine of kx kx this. So what happened is that you ask yourself, what function do I differentiate to get sine? And that is what? That is minus cosine. Okay. Then I divide the result by the coefficient of x, and that is k. Then I add my c. Okay. It's the same for this. It's the same for cosine. Okay. These results are so important. So let's take note of that. Very, very important. And the last example I want to talk about is the integral of 1 over x. And the result is always, ln x plus our constant c, or the integral of 1 over x will always be the ln of the modulus of x plus c. This is the case when x is is negative, and this is the case when x is positive. But usually we kind of assume that x is always positive. Remember that the natural log, okay, cannot assume negative values. Okay, so that's why we use the modulus here. Okay, so let's take note of that. And at this point, if you have not subscribed, please do so. Share my content, turn on your notification bell so that anytime I release new content, you'll be the first to receive that. Okay, very, very important. So at this point, I think it's good that at least we solve some questions. Okay, very, very, very important. So suppose I kind of give you some examples. So let's start with some examples. Very, very important. So my examples we have. So example one, we wanna evaluate e to the power 4x. Wanna find the integral of that. And according to the law, according to the the C law, okay? According to this law, law C, we claim that the integral of the e to the power, e to any power, what happened is that we maintain the integrand, which is e to the power 4x, then we divide it by the coefficient of 4 of x, sorry, and that is 4, then we add a constant c. Is that okay? Very, very important. So that's what we get for that. So this is the this is I, okay? What about if I give you, and the easiest way to, so we can always check, okay? So we can check, since we said that antiderivative is the reverse of differentiation, we can check our result whether it is true. So let's check it. So to check our result, what happened is that we differentiate the result, okay? And if you're able to get the original function back, which is e to the power 4, then it means you are right, okay? So we differentiate this. Now, when we differentiate this, what do we get? So we drop the 4, then we kind of multiply it by that. Then when we differentiate c, since c is a constant, we get 0, right? Very good. So at the end of the day, we're going to have e to the power 4x, which means whatever we did is right. Okay, very important. So at least we've checked that everything done is right. Good. So let's take note of that. Very, very important. All right. The second example is that if I give you let's look at a more a more detailed one, so that at least you would have a feel of what we are doing. So if I give you, the integral of 6 multiplying x to the power 5 minus 18x to the power 2 plus all of that dx. Now, with this law, which law can we use to do this? According to the linearity property says that you can do the distribution, okay? So we can distribute. According to the linearity property, it says that we can, distribute. So we can distribute as this, okay? According to the linearity property, we mentioned that linearity property would allow us to kind of do something else. So we said this one, we use the linearity property or principle, okay? Very, very important. So let's take note of that. Now, when we integrate this, we said that x to any power, what happens if you are integrating, what happens? We add 1 to the exponent and divide by the increased power, okay? So we add 1 to the exponent, then we divide it by the increased power. So that's what we were doing here. So we add 1 to the power, which is 2 plus 1, then we divide it by the increased power, okay? And what is the integral of a constant? 7. And that is what? That will be 7x, okay? Then we have to add a constant c. So to simplify this a bit, we kind of have 6 on 6 And I cancel so that we have 6 to the power that. So we have 18 on 3. And that gives us 9 x to the power 3 plus 7x plus c. Okay, so that will be our result. And the easiest way to check is to differentiate. The easiest way to check is to differentiate this. If you're able to get the original function back, which is the integrand, then it means that you are right. At this time, because of time, I may not have the time to differentiate the back. You may want to do it on your own, then you compare the result, and you should be fine. So let's go to the third example. With the third example, I want us to kind of, consider maybe, let's see, what I can give you some difficult one to try it on your own. So let me give you maybe let's say if I give you the integral of z to the power 6 plus 4z to the power 4 minus z squared dz. Okay. And over here, we by using the linearity property, we distribute, okay? And by distribution, we should have something beautiful as this. Now, when we integrate this, we say we add 1 to the power, okay? We add 1 to the power and divide it by the increased power, okay? Then we add a constant c to that. And that should give us what? 1 out of 7, z to the power, 7 plus 4 on the 5, z to the power 5, minus 1 over 3, z to the power 3 plus c. Very, very, very important. So this will eventually be our result. Okay, very, very important. And the last two examples that I want us to consider is if I give you the integral of 11 on x plus the cosine of 4x plus e to the power 4x. And by the linearity principle, we distribute, and by distributing, we should have something beautiful as this. Okay. And so according to something that we learned earlier on, we said that so when you have the you have the integral of 1 over x, then we said that this is what ln x, okay, plus c. So it's the same thing. We're going to leverage the same law over here. And by doing that, you should have what? Since 11, just a constant, you can push it outside a bit, okay? Then we can, then you can just, so if I were you, what happens, I can just get rid of this. I will just push the 11 outside so that I will have something as this. Okay. And then we know that the integral, then we know that the integral of 1 over x is ln. So then in that case, you're going to have what? You're going to have 11 ln x. Then I ask myself that what function do I differentiate such that I get cosine? What function do we differentiate to get cosine? And that is what? Sine, okay? So we get sine of what? 4x. Then what happens is I have to divide this by the coefficient of x, and that is what? 4, okay? Good. Then over here, how do I differentiate this? By differentiating this, I maintain the integrand, which is for e to the power 4x. I divide it by the coefficient of 4. Sorry, the coefficient of x, which is 4. Then I add my constant c. Okay, is that okay? This is very simple, right? It's very interesting. I know you would like it. It's just so interesting. And one thing, since we have been able to kind of connect the differentiation and then the antiderivative. I want us to see if I give you, you know, um, a differentiation and I want the function back. How do we do that? Okay. And that is our goal for this particular, problem. If I give you um, a derivative and I just find the function back, how the original function back, how do we do that? And that is our goal for this section. Very, very, very important. So I want everybody to pay much attention. We've got to a very critical point and in our discussion, and I do not want you to miss that. So our goal is I want to determine f of x given that f prime of x is equal to 6x to the power 8 minus 20x to the power 4 plus x squared plus 9. So that is the problem we are trying to solve right now. How do we solve this? Very, very, very important. Is if we think we have really understood all that we've done, then this is a very interesting problem. Usually, I like to give this kind of problem to my students just to test the understanding of the antiderivative. If they say they've really understood it, then this question should not baffle their mind at all. It shouldn't baffle them. All right, so let's get started. Now, how do I get the original function back if I have the derivative? How do I do that? How do we do that? Very, very, very important. How do we do that? Anyone? So you can put you can put your result in the comment section, and I would attend to you. Okay. Before we talk about this, I would like to guide you so that we all kind of have a sense of what is happening behind the scenes, so that we can really tackle this question in a very professional, very simple way. All right. So we know that we know that um, the antiderivative, or what we call the indefinite integrals, are asking us to undo a differentiation. A differentiation has been given to you. F prime is a differentiation, right? It has been given to you. So all that we need to do is that it's just to evaluate it's just to evaluate the what's the name? The indefinite integral. Is that okay? And I also want to remind you that the original function may have had a constant c on it, so you always have to add that at the result at the end of the result. Is that okay? I know. I mean, it's a first time, so let me take my time to explain that. Okay, so we know that the indefinite integrals are asking us to undo a differentiation, of which f prime is always being said differentiation. Okay, so all we are really being asked to do here is to evaluate the indefinite integral. Is that okay? Good. So anytime I want to point out that anytime, okay, I take the derivative of a differentiation, I get f of x. Okay, very, very, very important. Remember, we said that the antiderivative is the reverse of differentiation. Okay, so if I want the original function back, I just have to take the integral of that, and that is all very, very, very simple. Is that okay? Now let's go straight forward. Now it means that our antiderivative, sorry, our integrand is now the differentiation. And what is that? That is what 6 multiplying e to the power x minus 20 x to the power 4 plus x squared plus 9. Okay, very important. Now, by linearity property, we do our distribution, and if you have 6x to the power 8 dx minus Now, what's the integral of this? So what happens is we kind of add 1 to the power and divided by the increased power, okay? We add 1 also to the power, which is for that. Then we divide it by the increased power. We add 1 to the power and divided by the increased power, okay? Then we add a constant c. And as I mentioned, the c is so important, okay? Anytime we are talking about the antiderivative, the c, the constant c, as I told you, is very important. I remember this result is not unique, okay? It's not unique. And the reason is because the original function may have had a constant c on it, okay? And a c is just an arbitrary. C is just an arbitrary. C can be any, you know, um, in a constant value. Is that okay? Very, very, very important. So it just means this result is not it's not unique at all. Okay. Okay. So this is our result. Very, very, very important. Okay. So let's cut one more example. One more example. Then we say goodbye to this. So one more example. Then we say goodbye. So we wanna let me give you interesting one. So we wanna determine f of x such that f prime of x is equal to, instead of that, I wanna use a different one. We wanna determine g of x so that g prime of x is equal to the cosine of half x plus e to the power 10x plus plus 2. All right, so this is the problem we are trying to solve. If I were you, I would just, pause the video and try to do it on my own. And afterwards, I would just compare my result to what we're going to get. Okay. So as we mentioned, since we have the differentiation with the g prime of x, or for us to get our original function back, we just have to integrate that. Okay. Very, very, very important. So let's take note of that. So for us to get our g of x back, which is the original function, we take the integral of the g prime of x. Okay, very, very important. So we have the cosine of half x okay. So now by the linearity property, we just have to, distribute, okay? Okay, by distributing, now you ask yourself, what function do we differentiate such that we get cosine? And that is what sine of the angle. Then we divide it by with the coefficient of x, and that is what half, okay? And with this, we also said that we maintain the integrand and divided by the coefficient of x, and that is what? Minus 10, okay? And when you integrate a constant 2, we get what? 2x plus a constant c, okay? So this gives us what? 2 sine of So this is our result that we will get. Okay. And at this point, if you have not subscribed, please do so. Like, comment on the content, and share my kind of my content to your colleagues, to your loved ones. Let's help, create a community of mathematician, or community of people who are not afraid of mathematics. Some of the view that mathematics is difficult, math cannot be learned, math is only for the geniuses. But friends, that is not true. Okay, math can be learned, and as I mentioned, I mean, powerful platforms as this helps to kind of demystify those myths. So let's please help spread this good news. I believe this can help change destinies. Okay, stay blessed, and I will see you in my next episode. All right, bye bye.